Hello everyone and welcome to this video. Today we're gonna do uh, an exam revision for Calculus 3. As you can see, I'm gonna solve some questions here. So let's just get started. Now, back here. Okay. And so let's solve this question. As you can see, let's take a screenshot. We're gonna take it into a new sheet like this. And you're gonna add it. Okay, so and that's our question. And so he wants us to set up a double integral to find the surface area. So the surface area is just basically surface area is the square root of zx squared plus zy squared plus 1 and then dA, and that's our surface area. And now he wants us to find surface area of the part of the sphere. Okay, so we're gonna draw a sphere here. This is our sphere. It's 4 4, or actually the radius is 2, so 2 2. And then it wants us to make it lie inside the cylinder, which is x squared plus y squared minus 2y equal to 0. Basically x squared, yeah, so x squared plus y minus 1 all squared equals 1. So we actually add 1 here and 1 here. So like this, and then we take, this is basically y minus 1 all squared. And now this is our cylinder. Now let's just do this. So the radius of the cylinder is just 1. So that's our cylinder. Okay. And that's basically, so he wants to find the surface area of the part of the sphere that lies inside the cylinder. So he wants this part, this one, and also the other part here. So I think it's gonna be the same. So if we find this one, we can multiply it by 2 in order to find the total sum of surface areas. And so basically just find zx is equal to, now let's find z. What is z? Z equals to square root of 4 minus x squared minus y squared, and then after that we're gonna take zx, which is basically 2 square root of 4 minus x squared minus y squared, and then we're gonna have also minus 2x and 2 cancel, so zx equals to minus x over square root of 4 minus x squared minus y squared, and then zy is gonna be minus 2y, 2 square root of 4 minus x squared minus y squared, so zy, and so when we substitute this into s, we're gonna get s equals double integral of square root of, so when we square this, okay, of course this 2 cancels, so we get y squared over, okay, now we actually can convert, we're gonna convert to polar because it's easier here to use polar. So 4 minus x squared minus y squared, okay, and I'm gonna show you how we're gonna do that, okay, and plus x squared over 4 minus x squared minus y squared plus 1. Now dA, or we can do dx dy, it's fine. Now let's convert to polar. So basically the sum here, these two is just, or this becomes just y squared plus y plus x squared, since it's the same denominator, common denominator, so plus 1. So here up it's r squared, and here this is also r squared, but in the minus sign. So s is gonna be the integral of r squared over 4 minus r squared plus 1 dA. So now let's just add in the dA. So dA for polar is just r dr d theta. Now for the r, let's see what is the r gonna be. So the r is basically, we get it from here, or even from here it's just 1. Yeah, so is gonna make sure which R we use. Do we use the R of the sphere or the R of the cylinder? That's an interesting question. I think it's gonna be the R of the sphere or the cylinder. It's gonna be from 0. Of course, it's gonna be from 0, but up to certain value, and so it should be the R of the sphere. Okay, since we are not using the R of the, so set up a double integral to find the surface area of the part of the sphere that lies inside the cylinder. So we're talking about the sphere, really. And so R for the sphere is just 2, and the angle is just from, you're gonna take the angle from 0 to 2 pi. Should be from 0 to 2 pi. I assume to 2 pi. Now, how would this look from an upper view? Is gonna look something like this. Okay, and then R, R is gonna be 1. And so if R is 1, then we're gonna say just 1. And from 0 to 2 pi. So basically that's the surface area for one part. To say this is S. Okay, for one part, and then we can find the other S2. So now for this, basically we can use substitution rule. No, well, yeah. So did he ask? No, he didn't ask us to evaluate, and so we can say that this is the surface area basically. Okay, and so let's go. Oh, a different question. Let's check our answer. Did we do it right? So I see that there's x squared plus y squared z squared minus 4, and I see x. Okay. Okay. Okay, so he wrote the function in terms of f. Apparently, he wrote it in terms of f, and then he found fx for each of those. Okay, so it's not in terms of z. So let's just correct that. Okay, let's do it again here. Now I'm making a review, so you can review with me and also learn from. If I made any mistake, you can also learn from that, and also you can tell me the comments. Now I do have know that this is not very accurate, but basically we write it in terms of x, y, z if you have three variables. Now I did it as if we have two variables, but he said that the function is just f of x, or just we assume that the function is just f of x, so x squared plus y squared plus z squared minus 4 is just gonna give us f of x, y, z. Now we have also the cylinder squared plus y squared minus 2y equals to 0. This is our cylinder. And we do have also, yes, so now we need to find fx. That's very simple. 2x, fy is just 2y, and fz is just 2z. And now the surface area is now basically a double integral of square root. So it's actually correct what I did, but I did it in 2D apparently. So it's gonna be, and did he do a triple or double integral? Should be a double integral. So yeah. Also he did it r dA. There could be an issue here with this one. So we need to make sure that this is correct. Okay. To make sure that this is correct. Yeah, so the issue here is that we have three variables, but we have here two variables only. So, and we are evaluating a double integral, so we cannot have three variables. So I think what I did was the correct way. So we'll need to check this. I'll check it and get back to you. Now let's solve this question. Let's not look at the answer. Let's solve the second question and we'll get back to it to check whether this is correct or not. So now is our other question. So as I said, we are learning together. Now, okay, so it wants us to find the max and minimum values of f of x, y on the region. Okay, so we'll use Lagrangian multiply. No, we want to skip this question. Okay, we're gonna go to another question. So, yeah, in polar. Okay, yeah, we want this question. Let's take this question. Okay, and done. Okay, so first he wants us to set up a double integral in polar coordinates to find the volume of the solid that's above the cone 2z. 2z equals square root of x squared plus y squared in polar coordinates, so he wants us in polar, and also he wants us below the sphere xy squared plus t squared plus 4, and then we go this, and then this is our sphere, and we have also our cone, which is like this, and he wants basically the volume that is this volume above the cone and below the sphere. So this is basically just this, so like an inverted cone. Okay, no, actually it's not gonna look like this, it's gonna look something like this, like an ice cream cone. Okay, so that's our ice cream, and then you can draw some hidden lines. Okay, and so that's our volume. We want to find the volume of this using a double integral. So v equals double integral of, okay, so how do we find the volume using a double integral? So let's say we do z here, then dr, okay, so dA, so this should give us the volume. Now without this, this is gonna be an area, so this is gonna be an area. Now with that, we're gonna get a volume if we add z, and so we can find z, so z equals, we're gonna check this now also, y squared minus x squared square root, so z equals this. Now let's do the following. Let's do v equals the double integral of square root of 4 minus y squared minus x squared. Okay, so and then dr, so dA is just dr, yeah, dA. Now let's convert to polar. V equals the integral of 4 minus r squared, r dr d theta. Now r should go from, now if we draw this, it's gonna look like this from the top view. So if we draw, this is the xy plane. Now r here is just 2, so we're gonna have 2, so 0 2, from 0 to 2 r goes, and this is from 0 to 2 pi, and that's basically should be our volume. And that's, yeah, let's check. Okay, so z equals square root, okay, so square root of 4. I do see that some of what we did was correct. Okay, so we see that square root of 4 minus r squared is correct. Also, we do have minus r over 2, and I'm curious why is that. Okay, so we have here z equals square root of x squared plus y squared, that's the cone. Okay. Okay. So he basically just did, yeah, so he did basically this minus the cone. So the sphere minus the cone. So In order to do this, we don't have z. We have, let's say, sphere equation minus cone equation dA. Now, what is the sphere equation, which is the upper? So the upper minus the lower part of the volume. This is in order to find the volume using a double integral. So what is the upper part? We have the upper part to be the sphere. So, and the equation of the sphere we found it, which is the square root 4 minus y squared minus x squared. The minus the equation for z of the lower part, which is the cone. So this basically becomes z equals square root of x squared plus y squared all over 2, so minus square root of x squared plus y squared equals to 2 dA. Now this can become basically, okay, so yeah, so we were almost there. We just needed to also add, okay, the cone. And also I think there is a change in our boundaries. We're gonna make sure we are using the correct boundaries. So let's check here. So now here, so we're gonna convert to polar now. Square root of 4 minus r squared minus, so x squared plus y squared r squared and r over 2 times all times r dr d theta. Now basically, yeah, so now this is the integral now for the, and so theta is gonna be just, as you can see, yeah, so r squared plus y squared, okay. Okay, but how did we find 4 square root of 5 over 5? That's an interesting thing, and we can try to see how we find this angle. I would assume it's this angle. So, or actually, yeah, so R is this, and so R is here. So R is not the sphere, R is basically something different, and we can find it. So, yeah, so let's go back here. So, the reason he didn't, so R basically is from 0, but here R is not 2. As you can see here, R goes from, let's change the color. R goes from this point up to this point, and this distance is just not the radius of the sphere. It's just something else. So, and we need to find this distance. What is this distance? Well, let's try to find that. So basically, this is the intersection between the cone and the sphere. And so, in order to find the intersection, we can just go here and find the intersection by equating the two z's here and finding the values for y and x, and we're gonna get like the equation of the circle here. We're gonna see now. So okay, so let's equate these. So equate these. So square root of x squared plus y squared equals square root of 4 minus x squared minus y squared. And now squaring both sides is gonna give us x squared plus y squared equals 8 minus squared minus y squared. And now we add these, and so we have 2x squared plus y squared, 2y squared equals 8 divided by 2x squared plus y squared is going to equal to 4. So this is our intersection. I think, yeah, so yeah. So basically we move 2 here, and 2 squared is 4. Now 4 is going to be multiplying 4 equals, now multiplying the whole thing, so 4 like this. Okay. Okay, so yeah, so let's now, it's gonna be not 4, it's gonna be something different. So 2, okay, so x squared plus y squared equals 16 minus 4x squared minus 4y squared. Adding to both sides, 5x squared plus 5y squared. Okay, now it makes sense. 16. And now we divide by 5, so x squared plus y squared equals 16 over 5. And now that's basically our r squared. And so r is gonna be 4 over root 5. So that's our r, and that's our upper limit, so 4 over root 5. Interesting. And that's basically it. So that's 4 over root 5, but you know, multiplied by root 5 in both the denominator and numerator and got that value. That's the same thing. And for the pi, it's just basically the pi goes from, or theta goes from 0 up to 2 pi. So we're gonna be 0 to 2 pi. So we need to be careful when substituting the r, since it can be, it's not always the same r as the sphere or as, for example, our cone. So we need to find the intersection, and that's where our r is. That's basically it. That's how we find the volume in 2D. Now let's see our second example here, our second question. Now this is a different question. Let's go here and let's go basically here and add that question. Let's come here, and as we said, we're learning together. I hope while I'm teaching this, I also learn, and you also learn with me from the mistakes. So we basically we learn from our mistakes, and that's basically why we should be able to make mistakes and not be ashamed about it. And because that's basically how we humans learn. We learn by mistakes and errors. And so he wants us to set up a triple integral in spherical coordinates to find the volume of the solid that lies within the cylinder x squared plus y squared equals 2, and above the y plane and below the cone. Okay, so let's draw this. Okay, so we have first the cylinder with radius r equals root 2. Okay, so let's do this, let's do that, and then poop, poop, put. Okay, and this is root 2. That's our cylinder, and then we have the cone. 3z squared equals 4x squared plus 4y squared. That's our cone. Okay, interesting. Okay, let's assume the cone looks something like this. Like this, and then, ooh, love it. Okay, and then we want the volume basically. Okay, let's say that's, yeah. Okay, that's good. Okay, so he wants the volume. Of course, in spherical coordinates, he wants it. So spherical coordinates are basically not cylindrical, are rho, phi, theta. These are our spherical coordinates, and he wants us to be above the xy plane and below the cone. So within the cylinder, above the xy plane and below the cone. So something like this. So the volume is gonna be basically like this. Then it's gonna be going like this. The volume is just this area. Okay, so we want to find this volume. Now, how do we do that? So let's just first convert our equations to cylindrical or spherical coordinates. So he wants spherical, right? Yeah, he wants spherical. And so let's convert it to spherical. Now in spherical, I know that z equals r cosine phi, and rho equals r sine phi. Now for x and y, x is just rho sine phi cosine theta, and y is just rho sine phi sine theta. And also we know that rho is square root of x squared plus y squared plus z squared, and this is rho. And so let's now substitute our values. Let's substitute. So x squared plus y squared equals to 2 is gonna equal basically rho squared sine theta phi cosine phi theta plus all squared rho squared sine phi sine theta all squared equals to 2. Now, so can we simplify? So I see that we have rho squared sine phi, sine squared phi equal to 2. So we take this as common factor, these two, and cosine squared theta plus sine squared theta is 1, so we are left with this. So rho sine phi is just root 2. So that's our first equation. First, let's do the triple integral. So how would it look like? So we have this integral like this, and then so it's gonna be a triple integral. Now what about our functions? So how do we go about them? So first of all, we're gonna go for we're gonna find rho. Okay, so we're gonna need to find rho. So yeah, basically you can do just dv. I assume you can do dv, which is just our you know. So dv is just rho squared sine phi, as I remember, rho squared sine phi, d rho d phi d theta. Now that's what I remember. I hope I'm correct. So dv is just rho squared sine phi, d rho d phi d theta. And now for phi is gonna be from 0, and it's gonna go up to root 2 cosecant phi. So root 2 cosecant phi. That's our rho, and then for our phi, so phi is gonna go from this point, and this point is just basically we're gonna find it using the cone. So yeah, so we're gonna find it using the cone. So if we have this cone z squared equals 4x squared plus 4y squared, and now let's let, for example, y equal to 0. So let y equal to 0. We're gonna have just in the xz plane, we're gonna have something like this. So xz plane. And then we're gonna have 3z squared equals 4x squared. And so yeah, so x squared. Yeah, actually, you can also find phi from here. You can find it using converting to spherical. So let's convert to spherical. Let's try to convert to spherical. Let's see what we get. Now 3z in spherical is just r cosine phi equals 4 rho squared sine of phi cosine of phi. Cosine of theta all squared plus 4 rho squared sine squared of theta phi sine of phi. Now, so z, yes, r cosine phi or rho cosine phi. It is r cosine phi, okay. Oh, and this is theta. Now I want to do it the way I tried to do it first, which is let y equal to 0. So 3z squared equals 4x squared, and then tan theta is just gonna be z over x. Okay, and so if you find z over x, since if we let y equals 0, we're gonna have xz, we're gonna have something like this. And now this is z, this is x, and this is theta, so tan theta is z over x, yes. So if we come back here, so z squared over x squared equals 4 over 3, and taking the square root is going to give us z over x equals 2 over root of 3. Now tan theta, or tan phi, not theta, Actually, if you want phi is from the z-axis up to the line. So here, this is phi. And so it's gonna be x over z. This is x. And so yeah, so this angle, see, this is x and this is z. And this angle is phi, so tan of phi is just x over z. Phi. Tan of phi is x over z. And x squared over z squared equals 3 over 4, which is 3 root 3 over 2. And so tan theta equals root 3 over tan phi equals root 3, and phi equals 2. Let's find what is the value of phi. So if we take the tan inverse of this, it's gonna be some value. So it's gonna be tan inverse. Let's just say it's tan inverse of root 3 over 2, because we're gonna get not we're gonna get something like this. So it's not a whole number or a number of phi or pi, not a multiple of pi. So just keep it as it is. Now this is our phi. So phi is gonna go from 0. Now here it's gonna go from 0 and up to tan inverse root 3 over 2. And so lastly we have theta. Theta basically should go from 0 to 2 pi. Usually it goes from 0 to 2 pi. So yeah, yes, or xy, and just it goes from 0 to 2 pi. And that's basically should be our volume. Let's just check our answer. Okay, so yes. So first row will go from 0 up to square root of cosecant theta or cosecant phi. And actually I might have, yeah, so here it should go from not 0, sorry, it should go from, yeah, so since our phi, it's a bit confusing. So first of all we have tan inverse here of root 3 over 2. Okay, that's known. And then it should go from here up to 2 pi over 2. So the angle here from the z-axis up to this x-axis is pi over 2 and not 0. 0 is gonna be here near the z-axis or along the z-axis. So it's gonna be just the opposite of, so it's gonna be tan inverse of root 3 over 2, and here is 0. And here is gonna be pi over 2. And basically for our theta is from 0 to 2 pi. And this is just, yeah, that's basically our volume. And he's not, see, so do not evaluate the integral. He doesn't want us to evaluate the integral. And so now, let's see this. Okay, so change the following integral to cylindrical coordinates. Cylindrical coordinates, actually, I love cylindrical coordinates. I think they are a bit more easier than spherical coordinates, at least for me, or to me. I think they are a bit more easier. So, so the integral. Now we have 2, 0, have negative 2x minus x squared, 0 goes to x squared square root plus y squared, 2 minus x squared minus y squared, x squared plus y squared, 1 over 4, dz dy dx. Okay, so I could see r squared, and let's just change to spherical now. This, and then something here we have first start dz, and spherical dr d theta, and I think we should include r here. I think, yeah, I should include the r because this is dA. It's basically dA, and dA also includes r, so r dr d theta, yes, should include an r. Now here we have r squared to the power of 1 over 4, and this is basically 2 over 4, so r to the 1 over 2, and we have also an r here. Now, so square root of r squared, which is just r, okay, and then 2 minus r squared, that's basically simple to do. Now here we do have y equals minus square root of 2x minus x squared. Now how do we do this, how we go about it? So basically we can just, so we know that x equals cosine theta, r cosine theta, and y equals r sine theta. So y squared equals, if we square both sides, gonna be y squared. Actually, let's draw this. I think we should draw it. So in 3D is gonna be first a paraboloid, or we're gonna have a cone actually. We're gonna have a cone. Okay, that's our cone. And we're gonna have a paraboloid, which is like this. And the volume is something here. Okay, so our volume. And then, yeah, this is our volume. And then let's draw the xy. So xy, or let's say r theta, whatever you call it, for the polar. And then basically we would have something like, yeah. So let's try to find what is this. So this is y squared equals 2x minus x squared. So yeah, so if we take this y squared plus squared, or yeah, okay, so y squared plus x squared minus 2x, and we add 2 here, we add 2 here, we're gonna have y squared plus x, we add 1. Minus 1 all squared equals to 1. And it's basically a sphere centered at y equals 0 and x equals 1. So let's say something like here, this 1. And then let's extend this. And then it has a radius of 1, so something like this maybe. That's our sphere. We have the radius r. Okay, so, and also we notice that it's taking the negative only. So when we take the square root, he's taking the negative part, so when y is negative, so we're gonna take this area. And so this is basically just this shape, okay, like an ice cream cone shape, but it's taken in the half, so it's not taken as a whole, so it's like cut in half, and we're taking this volume only. So yeah, something like this. And so okay, we can basically just draw this, our little, part here, and basically, so R is gonna go from, here. So we have first, we said yeah, so 2x minus x squared. Now we have r sine squared theta, r squared equals 2 r cosine theta minus r squared cosine squared theta. And now we take r sine squared. Now, yeah, so let's just take this into one side. So r squared sine squared theta, r squared sine squared theta plus 2r cosine theta. And then you take r here, r, and then r equals 2 cosine theta. So that's our r. That's our r. But we need to make sure that we take the negative r. And so how do we make sure we take the negative r? So can maybe make sure that the angle, okay, so here we can just say this is our r, and then yeah, so then yeah, first thing we have z, and then we have r, which is 2 cosine theta up to 0, and theta now, theta is gonna go first from here, this is 0, it's gonna go up to 3 pi over 2, or negative pi over 2. So it's gonna go from 0 to, let's say 3 pi over 2, no, it's gonna, yeah. So we're gonna make sure also it goes this direction, so yeah, so maybe we can do something like, we can reverse this, so we have 0 and 2 cosine theta, okay, so bear with me, now 0, and but it goes from 3 pi over 2 up to 2 pi, or negative pi over 2 up to 0. And now this is basically the volume of the sphere. It's a bit complicated, but yeah, this should be the volume, hopefully. Okay, so yeah. So here, as you can see, this is our r, so r squared to the power of 3 over 2, 3 over 4. How did he get to 3 over 4? I'm not sure. It's 1 over... Oh, actually, in the question, it's 3 over 4, but for some reason, it's not. It's hard to read. So, yeah, so this is just... Okay. Yeah, so we have it 3 over 4, and so we'll have it 3 over 2 here. That's it, okay. So it's just hard to read from the question. You don't know if this is 1 or 3. Okay, and then we have, yeah, so r, and then for the r, it goes from r up to 2r squared. How 2r squared? So minus 2 minus r squared. Yeah, 2 minus r squared. Okay, I think he's mistaken here. So 2 minus r squared here. And then it goes from 0 to 2 cosine theta, that's correct. Okay, and then it's not from pi to 3 pi over 2, it's gonna go from 3 pi over 2 up to 2 pi. If we go from pi to 3 pi over 2, it's gonna be from here, and we don't have anything from here. We just it's gonna do something else, I'm not sure. But that's not how we do it. We just, as we did, so from 3 pi over 2 to 2 pi, or negative pi over 2 to 0, or 2 pi, negative pi over 2 to 0, and then basically, okay, and that's it. We have done it correctly. Now let's go to our... Okay, so we have here some MCQs. Let's see. So he's asking us here to find the length of the helix over t bigger than -1 and smaller than 2. And so in order to find the length of the helix, just take this, just copy both of these questions. We're gonna go over them. Now you add this, you zoom up, and then, okay, so we have our helix r of t equals 5 cosine of t plus t, of course, I, plus t j plus 5 sine of tk, and then t bigger than or equal -2, smaller than or equal to, that's my t. And basically the length, just the integral from -2 to 2, square root of, should be dr over dt, actually dx over dt plus dy over dt, plus dz over dt all squared x, y, z, and then dt. So this should be our length. And basically it's gonna be negative 2 to 2 square root of, okay, so it's gonna be minus 5 cosine of t, which is sine squared of t, plus dy over dt, so 1 all squared plus 1, and cosine, oh, actually we have also 5, so 5 squared is 25, sine, so 25, and then we have 25 cosine squared of t. Now L equals negative 2 to 2, 25 plus 1 is 26, dt. And now L is just minus 26 times t, negative 2 to 2. And it goes from 2 minus minus 2. So L is 4 root 26. Is this correct? Yes, 4 root 26. That's exactly what we get. Now for C, once to find the normal vector n of t of the curve r of t, e t cosine t, plus this t. Okay, so in order to find the normal line or the normal curve, it's relatively easy. So we know that n of t equals r prime of t, which is the velocity over the absolute value of r of t, r prime of t. And so we said r of t is just, here is given to be e to the t cosine of t. Okay, so r prime of t equals, so we're gonna apply the quotient, we're gonna apply the product rule. So let's write it in vector form. So e to the t cosine of t minus e to the t sine of t. That's for the x, and then we have e to the t sine of t minus e to the t or plus e to the t cosine of t e to the t. Now that's r prime. So we have r prime of t absolute value for square root of e to the t cosine of t minus e to the t sine of t all squared e to the t sine of t e to the t cosine of t is e to the 2t, which is e to the t squared. Now this can be also simplified, so can expand this, so we get e to the t cosine squared t, so we're gonna get some simplifications. Okay, let's expand. Okay, so we're gonna have some cancellation. No? No cancellations? Okay, we can simplify. So this and this is just e to the 2t. We take common factor, and then we're gonna have some cancellations actually. So this we cancel this, and then oh, so this is e cosine t squared. Plus 2t plus e to the 2t. And so it's equal to square root of 3 e to the 2t, which is e to the t. And that's basically the absolute value. And so the normal vector n of t finally is just our vector. Copy. And that's our normal vector. Let's check. Okay, we got something different. Why is that? I'm not sure. Oh, he wants us at t equals pi over 2. No, if we put in t equals pi over 2, what will we get? Ah, that's unfortunate. Actually, if we try to substitute here, will we get the value? I think we might get it. 1 over, let's substitute at t equals pi over 2. Let's try our solution. Okay, so I got negative 3 over root 3. Here he got negative 2 over root 2. So that's an issue. That's an issue. I think like this. So let's see what he did. So he got r prime, which is 1 over e to the t. For some reason it's 1 over e to the t. I'm not sure how did he get that. So yeah, so e to the t. Yes, it's e to the t. Cosine and then sine. Sweet. Root 2. Ah, okay. So let's see what happened here. Let's see what happened. One over root 2 here. So first of all, the value of r, he got it as root 3 e to the, just root 2, he got it as root 2, and he didn't get it as root 2, so why is that? Okay, so differentiating this with respect to t, will require us to use the product rule. So e to the t cosine of t minus e to the t sine of t. We can take e to the t as common factor. That's true, we can do that. Here we're gonna find absolute value. We're gonna get root 3 e to the t. So this is okay. So let's just come back to this and try to see what happened. So how did he get this? We're gonna try to understand this. Maybe use Euler a formula, which is Euler's formula. No, it's not. It's not this. It's just we'll come back to this and try to understand what happened. Okay, so xy. Okay, so let's solve this question. Now let's go here. So we're gonna come here now. He wants us to identify the surface with equation spherical coordinates given by. So this is our equation for sine of y, cosine of theta. Okay. Okay, so he wants us to identify this surface. Now let's convert to just regular coordinates. So square root of x squared plus y squared is z squared plus to 4 sine phi cosine phi, which is basically okay. So 4 sine phi cosine phi, this is x, so 4x. 4 times x. Oh yeah, so if we multiply by phi, both sides. So yes, let's multiply by phi, or rho actually, sorry, rho sine phi. This is phi, and this is rho. Cosine of theta, now this is gonna be just square, not square root, x squared. It's y squared plus z squared equals to 4x. So rho sine phi cosine phi is rho x. 4x, which is basically x squared x minus 2 all squared plus y squared plus z squared equal to 4. And that's basically a circle or a sphere, not a circle, a sphere of radius square root of 4 equals 2, centered at 2, 0, 0. Huh. Oh, so it's a sine here. It's not a cosine. It's a sine. So sine is gonna be just y. Sine is gonna be y, so it's gonna be different. If it was cosine, it's gonna be our equation. So it's x squared regular x squared plus y minus 2 all squared. And it's the same radius but centered at 0, 2, 0. And that's basically what we get. Alright. Okay, so we went over some questions. This was exam review for Calculus 3. I hope you benefited from this video. Thank you.